In this example, we look at hypothesis testing with one mean. Heights of people the same gender and similar age are approximately normal. You know from government data that the mean height of young men is 69.5 inches, and standard deviation of the heights of young men is about 2.8 inches. So we are going to treat these values as population data, so I've highlighted them. You work together with classmates to conduct a survey measuring the heights of 250 male students at LMC. The data is in the StatCrunch file named LMC random sample of 250 male heights. So let's go into StatCrunch and find that file. So in StatCrunch, instead of opening a blank StatCrunch, we're going to head down to Datasets, and we'll search for LMC male. And here is our file, LMC random sample of 250 male heights. So we open our file, and it's a raw data list of 250 male heights, and we can scroll down and see it goes down 250 rows. And so we are going to use this data for our hypothesis test. So you are fairly sure that the mean height of male students at LMC is greater than the mean height of all young men. All right, so that value for all young men, according to the government data, is 69.5 inches. So that's the value we're going to be comparing our mean to. We're going to carry out a hypothesis test for this claim. Since we have data about the population, the mean, and the standard deviation, this type of hypothesis test is known as a one-sample z-test. So our first step is to determine the hypotheses. So we first want to define what our mean is measuring. So our mean is going to be the mean height of the male students at LMC, and that's all the male students at LMC. And so our null hypothesis is going to say that the mean equals 69.5 inches, meaning the mean heights of LMC male students are no different than the population mean height of young men. And then our alternative hypothesis is going to say that the mean height of male students at LMC is greater than 69.5 inches. And we're using greater than because that was what was stated in our claim up here, where it says you are fairly sure that the mean height of male students at LMC is greater than the mean height of all young men. So in step 2, we're going to go into StatCrunch and collect and record the summary statistics. So I'm going to go back to our data file in StatCrunch and select Stat, Summary, Stats, Columns. So we'll go to Stat, Summary, Stats, and our data is in a column. And then I'm just going to leave everything highlighted so that I get all of the statistics. I don't need to record all of these. What I'm interested in is the sample mean. So we see here the sample mean from the sample of size 250 male students is 69.7832 inches. And then I'm interested in the sample standard deviation. That's the 2.8861. And the standard errors given along with the median and the range and the min, max, and the quartiles. So over here, I've recorded the sample size n, the sample mean, the 69.7832 inches. The sample standard deviation and the population standard deviation was the 2.8 that was given to us up here. So they're both pretty close. So now we're going to assess the evidence. So we're going to use, you could use a calculator, you could use StatCrunch, you can use a formulas to find the z-score and the corresponding p-value. So if we do it by hand, the z-score formula is to take the sample mean and subtract it from what we think is a population mean, the 69.5. And then because this is a sample of 250 males, we expect that the standard error is going to be smaller than the standard deviation, and our formula for that is to take the standard deviation 2.8 and divide it by the square root of the sample size of 250. So when we work this out, we subtract first on top, and then we divide by the calculation on the bottom, and we get right around 1.5992. I'm going to show you now how we can do this in StatCrunch. So in StatCrunch, we would go to Stat, Z-Stats, because we're using a normal distribution. And then we're going to go to one sample, and we're going to do this with data. We could also do it with summary and input the values we have. I'll show you how to do that as well. But since we've got the list of the data here, we could also use our data. So if we do it with data, we select the column heights of males. You could put in the population standard deviation. Let's go ahead and do that, the 2.8. And then we're doing our hypothesis test to compare to the height of 69.5 inches. And we'll do the greater than inequality. And then if we'd like to see the p-value plot, we can check here for optional graphs and tables. And here are our results. So they calculated the standard error for us using the standard deviation 2.8 that we provided. And here's the z-stat and the p-value. So those are exact matches for what we found by hand. So let's go look at what if we had done this with summary. That would be another choice since we have the summary data. So you go to stat, z-stats, one sample, now with summary. So here we have to enter the sample mean, the standard deviation, and the sample size. So the sample mean was 69.7832. The standard deviation we're using is a 2.8, and then the sample size is 250 male students. Our hypothesis is comparing the mean to 69.5, and we want to know if the mean of these LMC students is greater. And if we want to see a p-value plot, we can check the box here. And then compute, and you can see our results are the exact same. So either way, whether we use the data in the column in StatCrunch or whether we enter the summary data, we get the same results. Sometimes you only have the summary data because I've given that to you in the word problem. Sometimes you have a data file in StatCrunch and you could do it with data. So if we click over to look at the normal distribution, we see that we are a little more than 1.5 standard errors from the mean, and then our p-value is a bit above that 0.05 significance level. So that's going to help us write our conclusion. So by default, we use the 0.05 significance level. We are not asked to use a different significance level, so our preferred value is 5% room for error, 0.05 significance level. So we write our conclusion. We say the p-value is above the significance level, alpha equals 0.05. We fail to reject the null hypothesis. We don't have enough evidence to reject the null hypothesis. The mean of male students at LMC could be equal to 69.5 inches. So we are stuck with a null hypothesis. We don't have enough data to say that the mean height is greater for male students at LMC.